Hey Pulsar Pioneers, welcome back to the channel where we stare straight into the cosmic abyss and try to make sense of it all. You know, the universe is so ridiculously huge that most days we just go about our lives without giving it a second thought. But every once in a while, if you stop and really let the scale sink in, it hits you like a freight train. Billions of galaxies, stretching out forever, distances that laugh at the speed of light. And hidden in all that emptiness are phenomena that could wipe out everything we understand in the blink of an eye. Scientists, astronomers, and even a few stoned college students have been pondering these dark corners for years. And the more we learn with tools like JWST and fresh data from Gaia and Hubble, the more we realize just how fragile our little bubble of existence really is. Today, we're diving deep into the 10 scariest things the universe is hiding, all updated with the absolute latest research from 2025 and early 2026. No recycled old facts here. We're talking brand new simulations, fresh observations, and discoveries that have even the experts rethinking what they thought they knew. We'll count them down from number 10 to the one that still keeps me up at night at number 1. So settle in, maybe keep a light on, and let's get into it. Number 10. The Higgs boson doomsday, also known as false vacuum decay. Imagine the entire universe is sitting in a giant energy bathtub that isn't quite at the lowest possible level. It's metastable, like a ball teetering right on the lip of a hill instead of resting safely down in the valley below. All it would take is one random quantum fluctuation somewhere out in the vast emptiness, and a tiny bubble of true vacuum would pop into existence. Inside that bubble, the laws of physics would fundamentally change. Atoms would stop holding together the way they do now. Matter as we know it would simply disintegrate or transform into something unrecognizable. And here's the terrifying part. That bubble would expand outward at the speed of light, so there would be zero warning. 1 second you're here, the next, reality itself has been rewritten. Stephen Hawking himself warned about this possibility years ago, and recent work hasn't made it any less unsettling. The standard model parameters, especially the mass of the Higgs boson, around 125 giga-electron volts, and the top quark, still point to our vacuum being metastable. A 2024 experiment published in Nature Physics actually created analog bubbles of false vacuum decay in a superfluid system in Italy, with theoretical support from Newcastle University. They watched these bubbles form in a controlled quantum setup, giving us the first real experimental glimpse of how the process might work in the wild. Then, in 2026, a paper in Physics of the Dark Universe by Amartya Sengupta and colleagues explored possible early warning signals, transient gamma-ray bursts, and high-energy neutrino spikes racing just ahead of the expanding wall if the bubble moves slightly slower than light. A Slovenian team even recalculated the lifetime and found it might be only around 10 to the 790 years instead of even longer estimates. But that's still so far beyond the current age of the universe that it feels almost academic. Almost. Because quantum tunneling doesn't play by averages. It could happen anywhere, at any moment, without any buildup. And if it does, there is no escape. It is the ultimate doomsday that doesn't announce itself with fire or brimstone, just a silent rewrite of existence. The idea that the very fabric of reality could shift without warning is the kind of thought that makes you look at your morning coffee a little differently. Number 9. Galactic cannibalism. The brutal reality that bigger galaxies devour smaller ones like it's just another Tuesday in space. We've seen the evidence all around us. Andromeda, our closest large neighbor, has already shredded and swallowed a galaxy roughly the size of the Milky Way about 2 billion years ago. You can still see the faint stellar streams and shredded remains in its halo today. Our own Milky Way did the same thing roughly 10 billion years ago when it absorbed the Gaia Enceladus dwarf galaxy, leaving behind stars with weird chemical signatures and backward orbits as smoking gun proof. For decades, we assumed the Milky Way and Andromeda were on a collision course that would play out in about 4.5 billion years. But the latest 2025 research using the most precise Gaia and Hubble data has flipped the script. A major study published in Nature Astronomy by Til Sawala and his international team ran 100,000 detailed simulations and found there is now only about a 50-50 chance of a direct merger in the next 10 billion years. The Large Magellanic Cloud is pulling on us just enough to steer us away in some scenarios, while the Triangulum Galaxy adds its own gravitational tug that can either push us together or help us slip past each other with hundreds of thousands of light years to spare. In the cases where they do merge, the night sky would become an absolute light show as new stars ignite and gravitational chaos reshapes everything. But in the other half of the possibilities, we might just fly by in a slow gravitational dance, gradually settling into orbit around each other without ever fully crashing. Either way, the universe is littered with ongoing feasts right now. Galaxies are eating each other all the time because that's simply how they grow. It's a reminder that nothing in space stays peaceful forever, and the light show that would accompany a merger might be spectacular, but it would also mean total disruption for any planets caught in the middle. Number 8. The outcast supermassive black hole. One of those objects that makes you feel utterly insignificant. These are not just any black holes. They are the monsters that once sat at the hearts of galaxies and then got violently ejected into intergalactic space. The energy required to kick something millions or billions of times the mass of the Sun out of its home is staggering, equivalent to the output of 100 million supernovas, all going off in perfect coordination. The latest breakthrough came in late 2025, when JWST finally gave us ironclad confirmation of the first runaway supermassive black hole. It is tearing through a pair of merging ring galaxies, nicknamed the Cosmic Owl, about 8.8 billion light-years away. This beast is around 20 million solar masses, racing along at over 2 million miles per hour, leaving behind a glowing 200,000 light-year trail of newly formed stars. Astronomers spotted the long linear feature and the bow shock it creates as it plows through the gas, and follow-up observations nailed it as a genuine ejected black hole born from the chaotic merger of two even larger ones at the center of its original galaxy. The gravitational waves from that merger acted like a cosmic slingshot, flinging the survivor out at insane speed. Just think about that for a second. A black hole so massive it warps space-time itself is now wandering free, no longer anchored to any galaxy, potentially on a path that could intersect with others. These outcasts demonstrate how violent and unpredictable galaxy evolution can be, and they remind us that even the most powerful objects in the cosmos can be tossed aside like cosmic debris. Number 7. Rogue black holes. The ones that aren't supermassive but are still terrifying because they wander freely through space, completely invisible until it is far too late. Black holes form when massive stars collapse, and sometimes they get a kick from the supernova explosion or from gravitational interactions that send them hurtling across the galaxy at enormous speeds. In 2025, astronomers confirmed the first truly isolated stellar mass black hole drifting through the Milky Way, roughly 5,000 light-years away and about 7 times the mass of our Sun. It was detected through microlensing events, where its gravity briefly bent the light of a background star, and it has no companion to give it away with X-rays or accretion disks. It is just a silent, dark gravitational predator. Other recent finds include offset tidal disruption events, where a wandering black hole rips apart a star far from any galactic center. One discovered in 2025 by UC Berkeley researchers was 2,600 light-years off-center in its host galaxy, the first optically detected rogue of its kind. Estimates suggest there could be hundreds of millions of these stellar mass rogues roaming our galaxy alone. They don't announce themselves. They don't have glowing disks. They just sit there, warping space-time until something unfortunate wanders too close. If one ever passed near our solar system, the orbits of the planets could be thrown into chaos before we even realized what was happening. Number 6 zombie stars the undead remnants that refuse to stay dead. Stars are supposed to end their lives in dramatic fashion, either as white dwarfs, neutron stars, or black holes after a supernova, but some of them just refuse. We're talking Type 1ax supernovae, the wimpy cousins of normal supernovas, where the white dwarf survives the blast, charred and battered, but still glowing. Hubble caught one in 2025 that actually got brighter after dying. Then there are the magnetar zombies, neutron stars spinning so fast they shouldn't exist, or the ultra-slow ones, like ASCAP J1839-0756, discovered in 2024, that are rotating at a record slow pace and rewriting what we thought we knew about radio emission from neutron stars. Don't forget the white dwarf mergers that create massive undead stars that keep shining long after they should have fizzled out. Or the recurrent nova system, T Coronae Borealis, the blaze star 3,000 light-years away that is expected to erupt again as a zombie nova visible to the naked eye. Recent observations of the PA30 remnant from the 1181 supernova show strange, spiky filaments of hot sulfur that have baffled astronomers because they have held their shape for nearly 900 years. It's like the universe's version of the undead. They shouldn't be here, but they are. And some of them are speeding through space at ridiculous velocities. The idea that stars can cheat death and come back stronger or weirder makes you wonder what other rules the cosmos is quietly breaking right now. Number 5. Galaxies without dark matter. We've spent decades saying dark matter is the invisible glue holding galaxies together. Then we found galaxies that basically don't have any. NGC 1052 DF2 was the first shocker, followed by DF4, and in early 2026 we got DF9, the third confirmed member of this bizarre family, described in a new paper by Michael Keim and Peter Van Dockum from Yale. These ultra-diffuse galaxies are huge, but have almost no dark matter. Their stars orbit exactly as Newton would predict, with just the visible stuff. How? The leading theory now is violent bullet dwarf collisions that stripped the dark matter away like a cosmic game of pool. Another candidate, FCC 224, on the outskirts of the Fornax cluster, about 60 million light-years away, shows the same puzzling lack of dark matter with overly bright globular clusters that Hubble data confirmed in 2026 studies. It's not just weird, it's a direct challenge to everything we thought we knew about galaxy formation. If galaxies can survive without dark matter, what is it really doing out there? These discoveries are forcing cosmologists to rethink the role of dark matter in the early universe, and they open the door to the possibility that some galaxies might form in ways we never imagined. Number 4. The triple galaxy collision. 2 galaxies smashing together is rare enough. 3 at once? That's cosmic jackpot territory. We've seen them systems with 3 active galactic nuclei all lighting up at the same time. Massive starbursts cranking out hundreds of new suns every year. A 2025 discovery of the system J12181219 plus 1035 showed 3 galaxies locked in a slow gravitational dance, merging into one massive system with multiple black holes feeding at once. JWST has been spotting even wilder multi-mergers in the early universe, some involving 5 galaxies just 800 million years after the Big Bang. These events don't just rearrange stars, they trigger insane black hole feeding frenzies and scatter heavy elements across intergalactic space. What looks like a peaceful blob of light in the photos is actually 3 or more massive clusters of stars colliding and forming new stars at a furious rate of around 200 solar masses per year at the center. It's rare to see 3 galaxies do this, but the latest observations suggest it might have been more common in the young universe when everything was packed closer together. These collisions are mind-bogglingly humongous events that make our everyday problems feel tiny, yet they are happening right now somewhere out there, lighting up the cosmos in ways we are only beginning to understand. Number 3. The mystery of the biggest black holes in the early universe. Remember SDSSJ 0100 plus 2802? That monster quasar from the early universe with a black hole 12 billion times the mass of our Sun? It was already too big to exist when the universe was just 900 million years old. JWST has made the puzzle even worse. We've now found black holes growing at super Eddington rates, shrouded in dust, some powering little red dots that shouldn't be possible according to old models. a 2025 discovery of Canucks LRDZ 8.6 showed an actively growing supermassive black hole in a galaxy just 570 million years after the Big Bang, growing far faster than expected in such a small host. Another 2026 find revealed dust-shrouded quasars emitting energy equivalent to trillions of suns, powered by black holes of a few billion solar masses. How did they get so massive so fast? Direct collapse? Seeds from the very first stars? Or something we haven't even thought of yet? The fact that the early universe could cook up these monsters so quickly means our entire timeline of cosmic evolution might need a rewrite, and it raises the question of whether the first black holes formed in ways that defy our current theories. Number 2. The coldest place in the universe. Space is cold, but the Boomerang Nebula takes it to another level. At just 1 degree above absolute zero, colder than the cosmic microwave background itself, it's still the undisputed champion of natural cold places after all these years of observation. How? A dying star threw off its outer layers in a super-fast wind that expanded and cooled faster than the universe could warm it back up. It's been sitting there like a cosmic refrigerator for thousands of years, absorbing heat from the background radiation and staying colder than anything else we have found. ALMA observations back in 2013 and follow-up studies have confirmed the temperature at roughly minus 458 degrees Fahrenheit, and nothing has dethroned it yet. It's a stark reminder that the universe can get so cold that even the afterglow of the Big Bang feels warm by comparison. While it's still quite a bit away from us to be of any danger, it's one place we should all agree to never explore, in case we do figure out interstellar travel, because the kind of cold that exists there would turn anything we know into brittle, frozen nothingness in an instant. Number 1. Strange matter. For something named as inconspicuously as strange matter, you wouldn't think it would mean much. It sounds like something scientists came up with when they couldn't explain something and wanted to keep it for later. Look into the latest research, though, and you realize it is by far one of the weirdest parts of theoretical physics. In essence, strange matter, which may contain a lot of types of particles, isn't like anything we have seen before. Usual matter is made up of atoms with a nucleus containing protons and neutrons, which are in turn made up of quarks that stay neatly packed in, giving everything around us their unique properties. In strange matter, though, the quarks run free, with seemingly no boundaries or rules on what they are supposed to do. It is a completely different type of matter, and scarily, it could turn everything it comes in contact with to its own properties. Yes, a tiny lump of strange matter anywhere in the universe could be on its way here now, completely changing and essentially destroying the very nature of matter around it. Recent 2025 papers have revisited the idea that strange quark matter could be a dark matter candidate, and there are ongoing searches for strange stars, where neutron stars might have converted their cores into this exotic state. While no confirmed detections of stable strangelets have been made, the hypothesis remains active, because if even one negatively charged strangelet drifted into normal matter, it could start a chain reaction, converting everything it touches. Fortunately, strange matter hasn't been proven to exist anywhere in the universe, so it is only on paper for now. Unfortunately, recent observations of certain neutron star candidates and gamma-ray bursts, like GRB 240529A, have been interpreted by some researchers as possible hints of strange star formation, adding a fresh layer of intrigue and unease to the whole topic. So there you have it, Pulsar Pioneers. 10 things that remind us just how fragile and temporary our little corner of the cosmos really is. The universe doesn't care about us. It is doing its own wild, violent, beautiful thing out there. But that is also what makes it worth exploring. Every new JWST image, every fresh simulation, every weird discovery brings us one step closer to understanding, or at least appreciating, how lucky we are to be here, asking these questions in the first place. If one of these kept you up at night, drop it in the comments. What is the scariest thing in the universe to you? Hit that like button if you want more deep dives like this. Subscribe so you never miss an update, and I will see you in the next one. Stay curious. Stay safe out there in the cosmos.